The overall goal of this procedure is to collect, analyze, and display relevant human movement data in the shortest time possible. This is accomplished by first conducting a baseline movement analysis session to determine normal movement characteristics. The second step is to determine which movement characteristic will be modified based on the analysis of normal characteristics. Next, movement modification trials are conducted, which involves displaying real-time movement data in conjunction with a target depicting the amount of change to be achieved. The final step is to determine the effectiveness of the modified movement based on predetermined outcomes, and plan for subsequent sessions if appropriate. Ultimately, real-time movement modification is used to provide a quick and accurate method of changing movement parameters.
The main advantage of this technique over standard motion analysis is that there is no delay between the collection and analysis of data. This method can help answer key questions in the movement disorders field, such as which movement modification techniques are most feasible and which ones are most effective for restoring function. Demonstrating the procedure will be Judith, a graduate student from the laboratory.
To begin system preparation for this protocol, first clear the capture volume of any reflective material that may be observed by the cameras. This decreases the chances of actual skin-based markers being confused with stationary background markers during testing, and improves the overall accuracy of the session. Next, calibrate the cameras by aiming all cameras on stationary markers at fixed positions within the laboratory. Then extend the static calibration to dynamic movements using moving markers placed at known distances. Be sure to cover as much of the capture volume as possible to optimize the calibration. Now, organize all materials, including reflective